MCV4U1 Chapter 4, Session 10. In this session, we are working on questions from exercise 4.4. Question 1. For each function, state whether the value of the second derivative is positive or negative at each point A, B, C, and D. Part A. At point A, the derivative is 0. At point D, it is positive. At point C and B, it is negative. Question 2, Part B. Determine the critical point for each function and use the second derivative test to decide if the point is local maximum, local minimum, or neither. Y equals 25 divided by x2 plus 48. The first derivative of the function is minus 50x divided by x2 plus 48 to the power of 2. To find the derivative, we could use either the quotient rule or write it in the form of 25 times x2 plus 48 to the power of negative 1 and take the derivative. The critical point is 0 and 0. The second derivative of the function is negative 50 divided by x2 plus 48 to the power of 2 plus 200 x2 divided by x2 plus 48 to the power of 3. If we write the function in product form, we know derivative of a product is derivative of the first function times second function itself plus derivative of second function times first function itself. We get the second derivative. Second derivative at 0 is negative. Therefore, 0 and 0 is a local maximum of the function. By second derivative test, if at a point derivative is 0 and second derivative is negative, that point is local maximum. Next question, question number 9. Sketch the graph of a function with the following properties. F prime of x is positive when x is smaller than 2 and between 2 and 5. This means the function is increasing for x less than 2 and x between 2 and 5. F prime of x is negative when x is more than 5. This means for x greater than 5, the function is decreasing. F prime of 2 and f prime of 5, 0. That means the tangent line is horizontal when x is 2 and when x is 5. F double prime of x is negative when x is between 2 and 4 and greater than 7. For x is greater than 7 or between 2 and 4, the function is concave up. And when x is smaller than 2 and between 4 and 7, it is concave down. And f of 0 is 4, negative 4. F of 0 is negative 4. At 2 and 5, the tangent line is horizontal. And we know it is increasing when x is smaller than 2. And it is also increasing when x is between 2 and 5. We don't know the value of the function at 2 and 5, but since f of x is increasing when x is between 2 and 5, f of 5 is definitely greater than f of 2. The function is passing through 0 and 4, and it has a positive derivative b for 2 and between 2 and 5. When x is more than 5, it is decreasing. It's moving downward after. For x between 4 and 7, it is concave down. Between 4 and 7, it is concave down, and after it is concave up. For x is between 2 and 4, the function is concave up. Between 2 and 4, concave up. Less than 2, concave down. And after 5, it is decreasing. After 7, it is concave up. The graph of the function is something similar to what we sketched here. Next question is question number 10. Find constants a, b, c, and d such that the function f of x equals ax3 plus bx2 plus c. We'll have a local extremum at 2 and 11 and point of inflection at 1 and 5. 1 and 5 is point of inflection. And we have a local extremum at 2 and 11. The first derivative of the function is 3ax2 plus 2bx, and its second derivative is 6ax plus 2b. We know f of 1 is 5. That means a plus b plus c is 5. F double prime of 1 is 0. 6a plus 2b equals 0. F of 2 is 11. 8a plus 4b plus c equals 11. And f prime of 2 is 0. 12a plus 4b equals 0. You know, at any extremum, if a point is extremum, then the derivative at that point is 0. And if it is point of inflection, the second derivative at that point is 0. F prime of 1 is. F prime of 2 is 0. And f double prime of 1 is 0. We have 4 equations, 3 unknowns. But by looking at these equations, we see question number 3 and question number 4 are the same. Therefore, we use the first 3 equations. From the third equation, we have b equals minus 3a. And if we substitute it in first and second equation, we have minus 2a, a plus b is minus 2a, plus c equals 5, and minus 4a plus c equals 11. By subtracting this equation, we have 2a equals negative 6. That means a is negative 3. If we plug negative 3 into b equals minus 3, b would be 9. And if we plug a and b in the first equation, minus 3 plus 9 plus C equals 5, then C would be negative 1. This means for A equals negative 3, B equals 9, and C equals negative 1. 2 and 11 is a maximum or minimum for the function, and 1 and 5 is the point of inflection of the graph of the function. Thanks for watching.